Good morning. I am going to go over the assignment number 5 today and go step by step with you. We went through it last night, but it was a little bit quick as a class. And this way you can pause and go back and watch what I did again. So I'm going to do assignment 5 and go step by step, showing you how to do it with all of the nav tools. So here we go. Okay, so on number 1, it says you are sailing on a course of 298 per standard compass. At 0830, you take bearings using the ship's compass and find that Hoag Hospital bears 061 degrees PSC, and the southeast stack of the Huntington Beach power plants bears 007 PSC. What is your true course and what is the 830 position? So with the information given, we need to convert it to true so we can plot it on the chart. So everything we put on the chart has to be in true. So our first step is to make our, put it like that, make our, I like to do a table, and in this case, I'm going from compass to true. So I'm going to start with C, D, M, V, T, add east minus west. Okay, so that is compass, deviation, magnetic, variation, and true. And I want to convert my heading, and then I want to convert the bearing, that's the symbol for bearing, of the Hoag Hospital, and then also the bearing of the Huntington Beach PowerPoint. So what was given to us in the question said that our heading was 298. The bearing of Hoag Hospital was 061, and the bearing of the Huntington Beach Power Plant was 007. So I need to go to figure out my deviation so I can work my way down this math problem. So deviation is found on your deviation table. Now in our case we have a compass heading. Again, our deviation table goes with magnetic heading or compass heading. So we are going to go in with our compass heading of 298. So our compass heading of 298 is down here. I know it's hard to see, but if you have your paper you'd be able to see it. Our compass heading is 298, giving our deviation of 6 west. So I'm going to write in my deviation for 6 west. And if our heading is the same for all of the bearings, then the deviation is the same. So we didn't change heading, so our deviation is the same all the way across. Now, I want to figure out what that sign is. If I'm going down, I am adding east, subtracting west. So with this 6 west, I am going to subtract it. So I'm going to subtract the 6 west. And that leaves me with 292, 055, and 001, magnetic. Then I want to find my variation. Variation is on the chart. So if I look down to my compass rows down here, we have a variation of 12 east. So I know it's hard to see there. The variation is 12 east. So I'm going to have 12 east as my variation. And now I am going to follow my rules. Put it straight for you guys. Follow my rules of add east, subtract west. I have 12 east, so I'm going to be adding. And then I use calculator or do your mental math to get your true bearings of 304, 067, and 013. So those are our true bearings and our true heading. So we could answer number 1, what is your true course? Our true course was 304 degrees true. And now my next part of the question is, what is your latitude and longitude? So I need to plot these two bearings, and with these two bearings I plot the true. So I need to plot those two bearings from Hoag Hospital 067 and Huntington Beach 013. So let's do that. First we need to find those locations. We have the Hoag Hospital here and the Huntington Beach stacks right there. So I'll first demonstrate how to do it with the triangle. With the triangle, our Hoag Hospital bears 067. So I am looking for this focal point of the triangle and the bottom of the triangle to be on a vertical line at a bearing of 067. So I have 060, 070, 080. So I need to bring it around to a 067. And I like to pivot that around my pencil. So I put my pencil on the object in question and I push it up against it. So I have something to pivot on. And then I'm trying to align on this meridian the focal point of the triangle and 067. So you adjust and I have 067 and my focal point. So let me try to zoom in on that. Okay, so I zoomed in here a little bit, and I have the edge, so the long edge of the triangle is what we use to measure. The short edges of the triangle are how we move the triangle if we need to. And again, that's about 60% or 70% of the time we move the triangle. In this case, we don't have to. So I had my pencil on my point in question, and then I can use that as a pivot point to align the focal point, so where all of the lines come together, or there's a little dot on your triangle, and 067 on the same meridian. So there's this bold black line, that's a meridian line of 118 degrees west, and I have the focal point and 067 on the line. So then I push down on my triangle and draw my LOP, which is line of position. So I have my LOP for my Hoag Hospital. For the Huntington Beach Power Plant, my LOP is for 013 degrees true. Because that is really close to north or south, I am going to get that measurement on my triangle and then move it to the Huntington Beach stack, or the point of interest that I'm getting a bearing from. So using the same meridian, 118 degrees west, I am going to put the focal point on the meridian and then find 113, or 013. And I happen to already put it there. So I have the focal point and 013 all on the same meridian. So that means that this angle is 013. Now in order to move it to the power plant, which is right here, I use a straight edge or another triangle, whatever tool you have. So I'm going to put pressure down on the triangle itself. Then I'm going to bump up this ruler or straight edge next to it and put pressure on the ruler. So now with pressure on the ruler, I can move this triangle, and anywhere I move it, it is going to have this, I'm paralleling this angle here. So it is 013, 013, and then if I move it over to the power plant stacks, which are right here, it's still 013. So I'm going to move it in line with that power point, and then I can take my pencil and draw in the LOP line. So now I have an LOP as 013, and I have this LOP at 067. If I'm at infinite possibilities along this line, and at the exact same time, infinite possibilities along this line, I must be here. So I'm going to call that my 0830 position. Now my next step is to draw in my true course. So my true course was 304. So I'm headed up to Long Beach. I'm going to use that same meridian of 118, and I'm going to put my pencil on my position so I have something to pivot on, because that's where I want to start my line. Just like when I put my pencil on the hospital, that's where I started my line. Where I put my pencil on the stacks, that's where I started my line. So I'm starting my line from my position. So it's very close to the meridian, which is great, but I'm going to keep my pencil there and keep something to pivot on. So I have my triangle against it, and then I'm going to line up the focal point and 304 on the same meridian. So it takes a little bit of wiggling around here. So I have my focal point and 304 on the meridian at the same time. I push down and draw my course line. So this course is 304 degrees true. The next step is to, now that we've plotted that, we need to answer the rest of question 1, which is what is the latitude and longitude of this position. So I like to, as a beginner, draw in my latitude and longitude to the nearest bold black line. So to do that, I put my pencil on the position, and then I put my triangle perpendicular to the meridian. So I line up this line on that bold black line, and then I can draw in my latitude line. It is parallel to this line. With that line, I'm going to line up my triangle, so I have it pushed against my pencil where the position is, and then in line with the line that's perpendicular here. So that latitude line is where my black line is, and then I will draw a straight line. So this is the line of longitude, and this is the line of latitude. So I'm going to zoom out and show you how to read those. Okay, so now that I've zoomed out, we are going to read the longitude and latitude of our position. So I have drawn in the lines of the latitude and longitude. and we are going to read it over here on the right-hand side for latitude, and we are going to read on the top of the chart for longitude. So how we do that is with your pair of dividers. So I always like to line up on a black line, and I'm using the wheel to slowly but surely get my distance. So I have this is our spread from 0830 directly to the nearest line of latitude. So, or 0830, excuse me. I bring that over to the same line of latitude, and I can read. Let me zoom in. Okay, now that I've zoomed in on the latitude, you can see that with the dividers, you can measure from your position to the latitude line in question and bring that all the way over to the line and read what it is for latitude. So in this case, we have 33 degrees, 35 minutes. This right here is 36 minutes. So we have 36.123. 36.3. So when I have my latitude, I can say that this is 33 degrees, 36.3 minutes north. Now we're going to measure longitude. Let me zoom into the longitude. Okay, now we can see our position and our longitude, how we can read our longitude. So I am going to measure the distance from the black line of 118 degrees west to my position and bring that all the way up to the 118 and read where it meets. So it meets right about here. If this is 55 minutes, that means this whole section is 117 degrees, 55 minutes, 56, 57, 58, 59.123. So I can write in 117 degrees, 59.3 minutes west. And that's it. That's how we do problem number 1. Now I will show you again how to plot your LOPs using different plotting tools. Alright, now I'm going to show you how to get those same LOPs using the roll plotter and the parallel ruler. So we started with the Hoag Hospital at a true bearing of 067. So we have to reference a compass rose. We could either use this compass rose or this compass rose. We're kind of right in the middle, so it doesn't matter which one. I'm just going to use this one because it's closer to me. So I'm going to find 067 on the compass rose. Now remember, we're using the outer circle for true. So 067 is right here. So I want to line up the center of the compass rose with that 067. So I can either use the outside of the roll plotter or the black line. So I'll line up the black line. A little bit easier for me. So then I have 067 on my parallel plotter. You push down on the silver part and just parallel it up until you get to the hospital and draw in your line. Same with the Huntington Beach is 013. So with the 013, I'm going to start it pretty far up on the compass rose. So I'm looking for 013, which is right there. So I'll bring in my 013 is lined up, and I'm going to bring it to the Huntington Beach stack over here. So you push down on the silver and parallel it over. Draw your line. So again, where those two meet, you get your position. Now I will do it with the parallel rulers. Okay, now I'm going to show you how to plot the LOPs using the parallel rulers. So I'm going to put my pencil where the 067 is and line up so it touches the center of the compass rose. And then you do the walk up to the point that we have taken a bearing from. So you put pressure on one ruler, you can move the other ruler freely, put pressure on that ruler, then move the other one freely. Pressure on that ruler, we need to go a little bit farther. And we've made it. So there we can draw in our LOP. Same with the Huntington Beach, 013. Line it up on your compass rose, and then you're going to walk it back. So even if you lined it up this side, you can still take the bearing on the back side of the parallel rulers. So you put pressure on one, bring it over to the stacks, which not quite make it, so we'll shift a little bit closer. There we go. Now we made it over, we can draw in our LOP. So that was question number 1 on assignment 5. Now we'll do question number 2. Okay, moving to number 2. We have, while steering 107 PSC, Point Vicente light, that's up here, bears approximately 314 PSC, and Point Fermin, right here, bears 004 at 12 o'clock. So I'm going to do my conversions to true because they gave it all to us in PSC. So we have the heading of 107 Point Vicente at 314. And Point Fermin at 044. So we need to convert this to true in order to put it on the chart. Using our deviation table, we can go in with our compass heading. So compass heading would be our heading compass would be 107. So we have 093 to 018 gives us a deviation of 5 east. And our deviation did not change. Our heading did not change, therefore our deviation did not change. So we have 5 east, 5 east. If we are going this direction, we are going to be adding east. If you are going to be going down, you're adding west. We're going up. So we're going to add east. We get 1, 1, 2. Add east to this is 3, 1, 9. Add east is 0, 4, 9. Now variation is on the chart. On the compass rose, we have 12 east as our variation. 12 east. Again, that is east, so we are going to be adding it. So we get 1, 2, 4, and 3, 3, 1, and 0, 6, 1 for our true. So now I can go to the chart and use these as my LOPs from Point Vicente and Point Fermin. So I'm going to start using my triangles, and then I will use my other plotting tools. So Point Vicente is bearing 3, 3, 1. So I'm looking for 3, 3, 1, and we are not going to make it. So I'm going to go from here. I'm using the meridian for 118, 20 degrees. And I am going to put my focal point and 331 on the same meridian. So I have 330 and 340, so right there would be 331, and my focal point on the same meridian. Then you could use your straight edge, bump it up against your triangle, and move it over to Point Vicente. Draw in the LOP line. Now we want to make sure we're going from the actual light on Point Vicente. So the solid dot is where we're drawing the line from, not the actual point of land. Okay. Same with Point Fermin. We have 0, 6, 1. So I'm going to put my dot, my pencil lead on the dot of the light. And then I'm going to move this focal point and 0, 6, 1 to the same meridian. Right about there. Oops, I'm not against it. And then I draw my line. So my focal point and 0, 6, 1 are on the meridian as well as Point Fermin. So where those two lines cross, this will be my 12 o'clock position. And then next I'm going to put in my 1, 2, 4 as a heading. So in order to do that, I put my pencil on my position because that's where I want to start from. And then I want to find 1, 2, 4. So again, the focal point and 1, 2, 4. So I need to find where 1, 2, 4 is and the focal point. Right there, I have 1, 2, 4. And my focal point. So there I have my course line. Okay, back to normal lighting. Next up is to find the position of that location. So in order to find the position, again, I'm going to use my triangle, put in my lat and longs. So using the triangle, I put my 90 degree right at the close meridian. Therefore, I can draw in my latitude line, same with the longitude line. And here we're in the corner, so it might be easier to use a different tool, but for latitude, we're going to look it up here and bring it all the way over to say our latitude is 33 degrees 40.4 minutes. You can see that. And then for longitude, we're going to get that difference. And we are going to get 21.8. So that's 20, 21, and 0.8. If you can tell. Okay, also you can use the roll plotter. So finding lat and long with the roll plotter, you line up your, you might be very close to the edge here, so you could line up your latitude line with the line in question and move it right up to our position and then draw in our latitude line. Same with longitude, because we are so close to the edge, we can line up our longitude, then roll it over and mark our longitude line. Okay, so on number 3, we are down on Catalina using Shiprock and Long Point. I'm going to show you another way to calculate compass error. Again, this is the same concept, just a different layout on the whiteboard or your scratch paper. So I'm going to use can, did, min, vote twice at elections. So going this way, we're going to be adding east. I'm going to be looking for my heading, my Shiprock, and Long Point. Okay, so they gave us our heading as 160 compass, and then they told us using our hand bearing compass, we take bearings. So when we use the hand bearing compass, it gives it to us in magnetic, not compass. So our magnetic reading for Shiprock was 234, and our magnetic reading for Long Point was 157. So for deviation, it only matters for the heading conversion because we did not use the compass for our LOPs. We go to the deviation table and find our compass heading of 160 to be 0 degrees. So our compass is actually the same as magnetic. Our variation, again, is on the compass rose as 12 east, 12 east, 12 east. If I'm going this direction, I'm adding east. So I get a true of 172 and 246 and 169. So these are my true that I can plot on the chart. Again, I'm going to start with my triangle and then use the roll plotter. So for Ship's Rock is right here at Two Harbors. We had a bearing of 246. So I'm going to put my pencil right on the light at Ship Rock. And then I'm going to find 246 on my bottom of the triangle using this meridian line. So that was 118.30 degrees west is my meridian line. And I'm going to put my focal point on the meridian line and 246 on the meridian line. So I line that up as best as I can. And I also have my pencil on Ship's Rock. I put pressure against it so that I have that something to pivot on. So 246. Alright, then I'm going to draw in my LOP. And I actually know that this isn't quite going to reach. So I'm going to use my straight edge, bump it up against my triangle, slide my triangle a little bit further, and draw a little bit further of an LOP. We always want to draw that line on the same triangle or instrument that you are using. Instead of drawing it here and then adding, it can just be a little bit different of a line. Okay, so that's our LOP from Ship Rock. From Long Point, we had 169. Now 169 is pretty close to vertical, so I'm going to end up having to move my triangle. So I'm going to line up on the meridian. This is 118:20 minutes, the focal point, and then I'm going to find 169 here at the bottom. So I have 169 and the focal point, and then I'm going to bring it over to Long Point. So let me get that better here. We got focal point on the meridian and 169. Then I'm going to bump up my straight edge, put pressure on my ruler now, and now I can slide a parallel 169 from Long Point all the way up. And now where those two lines meet, that is my position. And this was at 1800. Now I need to get my latitude and longitude. Or, no, actually first I will do my course. My course was 172. So again, that's real close to vertical. So I'm going to put in my 172. So again, focal point on the line and 172. Then I bump up my straight edge against the triangle and move it over to my position. So I'm pretty much headed towards Long Point. Now I'm going to find my position. We are just above the latitude line there, so we're probably at 33 degrees, 30 minutes, and a little tiny bit. And then for longitude, we can use our dividers. do my longitude correctly. Down here at the bottom, we get 20, 21, 22, 23.3 or 4, something like that, right in the middle there. And then for our latitude, we can go right above there, and we get about 1/10. So that would be 33 degrees, 30 minutes, 30.1 minutes. If we were doing this with our roll plotter, we would be using the compass rose down here. More of the compass rose here. So we can use the compass rose to find 246. Sorry, where's 246? 246. I'm going to use it over here. Push up against the metal part and roll it right up to ship's rock and draw in your line. For the 169, we can find 169 and then roll it over to long point and draw your LOP. So that's using the roll plotter, same type of thing with the parallel rules. For the position, we can reach for our latitude, so we can line up our line and bring it down. For longitude, we can't quite reach, so you might have to put an extension on it. Make sure you have a nice straight vertical line. So I'm lining up my vertical meridian, paralleling it, and then I can bring it over to the line of interest and draw in my longitude line. All right, let's do number 4. Okay, so on number 4, we actually don't have to convert any bearings. We have 2 ranges. So it told us at 9:45 the oil platform EVA, which is located right here, is bearing 3.9 nautical miles. And then our LB buoy, which is right here, has a range of 3.5 miles. So how we need to plot this is by using our compass tool, not our divider tool. So again, our divider tool has 2 pointy ends, and our compass tool has a pointy end and a pencil end. So if you please do not try to scratch or tear your chart by marking it with 2 pointy ends. It is much easier to do it on a pencil, and you can just twist the black knob off and pull out the pointy lead and put in the pencil lead. So yes, that takes a little bit of time, but if you know you are getting some ranges, it's a great tool to just have a compass on hand, so you can have your range LOPs. Okay, so I use the latitude because 1 minute is equal to 1 nautical mile to get my range distances. You can also use the distance scale. Okay, so EVA is 3.9 nautical miles, so I'm going to find 3.9 nautical miles, and I can make an arc there. So I know that this is 3.9 nautical miles. Now I'm going to bring it back over to the point of interest and make my line of position. Okay, so I still have the 3.9 nautical miles, and I'm going to put the pointy end on my point of interest, which is the oil platform EVA, and then I am going to scribe my line of position. So this is telling me that I am anywhere along this line. Infinite possibilities. But I have one more piece of information that says the Long Beach buoy is 3.5 nautical miles. So I'm going to find 3.5 on my dividers. 3.5 right there using my dividers. Okay. Now I'm going to make sure I correctly identify the buoy that I am getting the range from. In this case, it has a Raycon, so that would help me identify it. And scribe my line of position. So with this information, I am somewhere along this line and this line. So that gives me two possible positions. I have this position and this position. So I need another piece of information to say which one I am at. And you can either look out the window or you can read the question. And the question tells us the depth sounder reads a little over 100 feet at the time of the ranges. So we want to find what 100 feet would look like. This chart is in fathoms, so I need to convert fathoms to feet. Okay, so down at the bottom of the chart is where we have our fathoms to feet to meters conversion. So if we had our fathometer read 100 feet, here's 96 and 102, so somewhere in between, that would be 16 and 17 fathoms. So I'm looking for 16 or 17 fathoms to equal 100 feet. So let's go back and look for that. Okay, so we are looking for somewhere between 16 and 17 fathoms. So our fathom range at our first possible location would be about 7 or 8 fathoms. The depth at our second possible would be, here's a 15 and here's a 17. So probably be between 16 and 17. So I would say this is our position. In order to get lat and long, you can use the roll plotter to get latitude. Longitude is right in the middle, so it's a little more difficult. I would get, I'm going to show you, since we have the dividers or the compass out, I'll show you another way to get your latitude and longitude. You can put so here is my position. And I can use my dividers by scribing an arc, so where it only passes through once, right about there, would be my shortest possible distance. And then I use that to see my latitude, and same for longitude. You'll be able to see this one. Then you could bring it up here and scribe. Okay, so for number 5, we are talking about West End, and at 1430 we get a bearing of West End using our handheld compass, so it's 190 magnetic, and then we also have a range, so our range was 8,000 yards, or 4 nautical miles. So we are going to plot. Well, first we have to convert our magnetic to true. So in this case, we can do, we're starting off as magnetic. So we have 190. And our variation was 12 degrees east. Again, that was from the compass rose. So we get a true of 202 degrees true. So now I can plot 202 degrees and then get my range. So I am going to first use my triangle to get 202, which is pretty close to vertical. So I'm going to do it here as my focal point, and 202 are on the same meridian. And I will use my ruler to slide it over to West End Light and draw my LOP. Then I have a range of 4 nautical miles. So I will use my compass and get 4 nautical miles right about there. Put the point on West End and scribe my arc. So I have this as my position at 1430. From there, I can get my latitude and longitude. We're right next to the latitude, so we can just draw that over for longitude. Distance here, which is the same as here, which will be the same as here. So I can read my longitude, or first latitude is 33 degrees, 32 point about 4 or 5 minutes north, and then my longitude is 118, and this is 30, 31, 32, 33, 34.6. So that's how you get longitude. If you're using a roll plotter, you can use this one up here or this one over here. Let's try this one up there. So we were looking for 202 right about about there. And then you could roll it back from west end and draw your LOP line, and then same for your distance. This one doesn't quite reach for the longitude either. Using the roll plotter for latitude and longitude, you'd have to use an extension to get all the way down. I didn't start there. And there you go. Latitude, line it up, and strike it over. All right, please let me know if you guys have any questions about this assignment 5, and I will talk to you guys on Wednesday. Thanks for watching.